Another topic we have to deal with in the equilibrium chapter is LeChatlier's principles. And LeChatlier's principle basically says that if I have a reaction that's already at equilibrium and I do something to change the conditions, I add more product, I add more reactant, I somehow take out some product or take out some reactant, then I'm going to disturb that equilibrium and it will have to rebalance things to make a new equilibrium. When a stress is placed on a reaction that's already in equilibrium, the reaction is going to shift in the forward direction or the reverse direction. So in the direction that relieves the stress. That's what it says. The K value, remember, is something that's a number that's equal to a ratio of products over reactants using that K expression. And that number can't change. So in other words, I have to keep the top and the bottom at that same fraction. And so to do that, I'm going to have to adjust some concentrations. Let me show you how we would figure this out. I've really written it down for you. There's 4 possibilities. There are lots of ways I can stress a reaction at equilibrium. The only ones I need you to be concerned about is what would happen if I change the concentration of one of the reactants or of one of the products. So there's 4 possibilities. If I add additional reactant or I increase the concentration of the reactants, the stresses the reactant and the reactants will form products. So the forward reaction, it shifts in the forward reaction to reduce the stress. So if we add additional reactants, it's going to shift in the forward direction or shift to the right because the products are on the right, or shift to products. If we remove some of the reactant, and there's a lot of ways I can remove reactant. One way is that I can put something else in there that reacts with the reactant and kind of eats it up. So if I remove some reactant, then the stress side is the product side. So it will react in a reverse reaction, or it will shift towards reactants. It will shift to the left to relieve the stress, and it will end up forming more reactants. If I add additional products, there's 2 cases I can do to the products. I can add additional products to the reaction, and it will stress it, and the products will form reactions. So I'm going to add more product. It's going to shift the reaction to the left or towards reactants to form more reactants. And if I remove some product, it does the reverse. It does the opposite. If I remove some product, it shifts it in the forward direction, or shifts the reaction to the right, or it shifts towards products to reduce that stress. Another way we can do this is to kind of use the seesaw method. Again, here we go. Add reactant. It's going to increase the forward reaction rate, speeds it up for a little bit until it reaches equilibrium again, and it's going to shift the equilibrium to the product side. If I remove reactant, the forward reaction slows down for a little bit, and it shifts the equilibrium to the reactant side. If I add product, any one of the products, reverse reaction speeds up for a little bit, and it shifts the equilibrium to the reactant side. If I remove product, the reverse reaction slows down for a tiny bit until it reaches equilibrium again, and it shifts the equilibrium to the product side. So there's 4 possibilities. I can also use a seesaw method to get the same answers. And in this, if you want to use this method rather than memorizing those 4 possibilities, I visualize the equilibrium as a balanced seesaw. I'm going to draw a line through the chemical reaction and imagining that there's like a pivot point underneath the arrow. If there's an increase in a particular chemical, I'm going to put an arrow underneath that chemical pushing the line up. If there's a decrease in a particular chemical, I'm going to put a down arrow on top of that chemical, pushing the line down. And then I'm going to envision what would happen to my line. So here I have my line, here's my arrow, so I consider this is where it bounces. If I'm adding a reactant, I'm going to be pushing up on the line. Note that the line would switch this way and things would roll to that side, so it's going to roll towards the product side. If I were removing reactant, I'm going to push down on that reactant side. Note that now it twists the other way it rolls down to this way, and we're going to say it's going to shift towards the reactants. I can do the same too on this side. If I increase the amount of product, I'm going to push up on the line. It's going to shift towards reactants. If I'm decreasing product, I'm pushing down on the line, and it shifts towards the product side. Let me show you some examples. So if I remove ammonium from this system after it's at equilibrium, here's my ammonium, I have my line through it, so if I remove it, I'm going to be taking it down, I'm decreasing it, so I'm going to put a down arrow on top. That's going to push this line this way. It's going to push the line down on the right-hand side, and note that now if I were to put something on this, everything's going to roll towards this side. They're rolling towards the product side. So I could use words like it shifts towards products. I could say it shifts to the right. Any kind of words like that. Favors forward reaction, it makes more product. All of these are sort of saying the same thing. If I had hydrogen to this system after it's at equilibrium, and this was now hydrogen plus chlorine makes 2HCl. I put a line through it. If I add hydrogen, again, here's my hydrogen, it's a reactant. Adding it, I'm going to push up on the line. I'm going to put an up arrow underneath it. And it's going to move the line this way. It's going to push up on the left side and tilt it this way. Note that the same thing happens. If I put everything on it, it's going to roll towards the product side. So I'm going to shift towards the products. I could also say it's going to favor the forward reaction. I could also say it shifts to the right. I could also say it makes more product. They're all saying the same thing.